Okay, this video's doing one of my favourite exam questions for centre of mass. Now there's two approaches to this one. I'll go through the second approach on this first part in a separate video. The two approaches consist of breaking the shape down into easily calculable and findable centres of mass. So we've got a centre of mass of O, there's a point X, OXCD, the centre of mass is going to be right in the middle, and we know that's got the centre of mass is going to be A and 3A. We've got another one here in the second region, which is going to be 2 across to here, and then this 4 is split in 2. So these rectangles are evenly spaced. There's the centre of mass for that one. And then the triangle, you have to find the midpoint, and the centre of mass is 1/3 of the way from the base to the apex, or 2/3 of the way from the apex to find the centre of mass for that point. And you have to do that individually to create our tables, create our formulae. Now, if you follow the way the book goes about it, they create the centre of mass G for the whole object. That's G. And we have to have some form of mass coefficient or mass representation. Just for 3 users, I tend to actually keep using the same notation. So this is a uniform laminar, so every unit of area in this region has the same mass as a unit in this region as a unit of mass in that region. So the mass for this one is going to be 6 2's 12 a squared, and then to actually give it a mass I need a density function. They all cancel out, don't worry about them. Then we've got our 3 regions. We've got region 1, region 2, and region 3. And sorry, that was for region 1. So region 1 is 12a squared is the area times the density of the mass per unit area. And there's my mass representation. I need section 2. Section 2, again, this time it's 4a along this side, so again it's 12a squared, and it's got the same density function. And section 3. Section 3 has the mass. It's a triangle which is 3 high, 4 wide, so it's half of the 12a squared, so it's 6a squared. Well, and we get our overall shape G, which is the sums of all those masses. So we're going to get 30a squared rho. Now the advantage of drawing the table is at this point you can see that both sides of my equation I've got a squared rho in all terms, so I can cancel through by the a squared rho. You can also even cancel through by 6a squared rho. So we're going to cancel a squared rho and 6 lots of it, which gives me a mass. This part is worth 2 units of mass, this is 2 units of mass, that's 1 unit of mass, and that one is 5 units of mass. And they're the numbers I'm going to use. You could have more complicated formulae using these. This is the advantage of using that table, though, is that sort of cancellation appears a lot more readily than when you write it out in algebra. The next part is we need to go through and calculate where x and y coordinates are. So for A, the x coordinate is at A, the y coordinate is at 3a. 2, it's 2a from there and then half again, so half of the 4 is 2, so it's 4a. And it's up 3 halves of A. Regions 3, we're going to need a diagram for in a moment, and I'll draw that diagram to do this section in between. And G, its coordinates are x bar and y bar. So now I need to get the diagram for the triangle at the top so I can find its centre. So the centre of this triangle we know this bottom point where the right angle is 2A across and 3A up. So I'm just going to add that to my diagram. I'll add it when I can get the pen working. So 2A and 3A is the coordinates at that point. Along the line, I'm going to go 1/3. To that distance there is 2A, and to that distance up the side is 3A. So this halfway point is going to be 3/2 of A, and we want to go 2 parts up of that 3/2 A. That means that we actually want a height which is just A. And distance across it is going to be 2/3 of the way across the 2, which is 4A. So now we add these onto our coordinates for this bottom corner. So 2A plus 4, 3A. That's going to give me 10/3 A. And vertically, we've gone up 3A and we've got a 4th one. So that's 4A. Now we can create an equation to solve and find out what our positions are, X bar and Y bar. So total, we use the values 2, 2, 1 and the 5. They're the coefficients I need. And I will use vector notation. You can do them as resolving in X and Y, but I'm building in using vectors throughout. So for this sort of equation, I prefer column vectors. So 2. So this was mass 2, 4A, and 3/2 A. And the last one was a single unit of a vector, 10/3 A. And 4A. The final point was a total mass 5, centred at the point G, X bar, Y bar. The bars being averaged. Evaluate everything through, so we get 2A plus 8A plus 10/3 of A. Top, and we get 6A plus 3A plus 4A on the bottom, and that is all multiplied by 1/5 to give us X bar, Y bar. Sum the top and put it into a single fraction, so we're looking at in thirds, we're going to have 6, 30, 40A, and we want to divide that by 5, and on the bottom we have a total of 13 to be divided by 5. This gives me my X bar, Y bar, which allows me to get 8/3 A as being X bar. And X bar is my distance from OD. Because the question actually asked from OD, which is the vertical side, that gives me my X distance for the centre of mass. That's part 1. Part 2 is COM from OA, and that's the distance from the bottom. That is equal to 13 for 5A. So that's the first part of the question done. The second part, way to do this one is you can actually take this square of 6A, 6A and subtract a mass in the corner, and it will give you the same result. If you don't do the simplification, that's fine, it would still carry on going. So let's go on to part B, which is about the angle the sloping edge makes. New copy of the picture so we can talk about it. Okay, for part B, we now need to find where does this line CB wind up when it's dangled from C. Now the point to remember is C, we've got 8/3 of the way across from A. We get our centre of gravity is in here. And the centre, if we're suspending from C, that line will always go vertical. So that's the vertical line they're talking about, this shape making. The way to about calculating the angle from the normal. So we need to know, first of all, the angle at C, which is a simple piece of trigonometry. So there's an angle it makes to the normal starting with. And when it's dangled, we need to know this angle beta, which is how much the whole string twists so the gravity is the centre of gravity is below the point C. That C is another little triangle, and we need to get the lengths on there, and they come from part A, the difference between point C across and where G is across. So x bar minus the 2A for point C, and that's the base of this triangle here, and that works out as being 2/3 A. The vertical distance here is the height above B, so it's 3A on that side. So we can calculate the angle B, beta, calculate the angle alpha by using this length here, which is 4A, and this length here, which is 3A. So question B, angle alpha is the inverse tangent, or tan minus 1, or arc tangent of 4A over 3A. Of course they cancel. And beta is the arc tangent of the opposite side, 2/3 A over 3A. And the A's cancel. So our angle is going to be, calculate the inverse tan. Make sure you're working in degrees for this one. They don't always tell you which one, but I'm going to use degrees. Tan of 2 over 9. And that's 12.53. Ooh, my y direction on this is wrong. Yeah, because it's going to the gravity, not to the point B, so this fraction is all wrong. Let's redraw that one in a minute. So this distance here to the centre of gravity, not to the bottom line here, that's 6A minus the position of gravity. 6A minus the gravity, which is 13 over 5A, which equals 30A minus 17, that's going to be 17A over 5. Now we've got the numbers to work for beta. So angle alpha is inverse tan 4 over 3. That's 53.1. Make sure you're doing more, at least one decimal place in the working, because it does say to the newest degree in the answer. And it actually does say in the question it was to the minimum. That angle. Again, do the tan. So we've got 2/3 of A over 17/5 of A. The A's cancel. And that simplifies to 10/51. So the angle beta and that's 11.1 1 degrees. So BC to the vertical is the difference between these two. And that's 42 degrees. That's that connection complete.